Next will be stretch and compression of functions. So given some function y equals f of x, it will be vertically stretched or compressed by a factor of a when we're given this function y equals a f of x. We've seen this before. Okay, the number out front of the function tells us what's happening to the for the stretch and compress. And mechanically how we do it is we multiply the y coordinates by whatever that a is. So for example, here we have some basic function and we're told to stretch it y equals 2 f of x. So our a is 2 sitting out front, and this 2 here. What I do is I simply multiply my y values by 2. So this 5 gets multiplied by 2, which is 10. This 2 here gets multiplied by 2, which is 4. This negative 7, and so on. Negative 7 gets multiplied by 2 way down here at negative 14. And we see that the function is stretched, or it's opened up or pulled apart, or stretched vertically. So same idea here, given some other kind of function. The blue one is y equals f of x. If I make it 2f of x, it basically doubles in height, so it becomes twice as high. So if that was like a 1, that would be a 2. Or a fraction, and we can multiply it by a fraction, and that's fine. 0.5, sometimes we may see that as a half, that's fine. Multiplied by a fraction, that just compresses, it's called this compression, that shrinks everything down, and it wouldn't go nearly as high. Maybe that's 0.5 in terms of its height. Here's just an illustration here. You're going to see 2, 4 coming up right there. There's 1.5. These factors, a up front, there's our 2, 4. That's 3/4, there's a half, there's a fraction, 0.25 is another fraction, 0.1 is a tenth, that's a 0 that wipes it out. And of course, we can multiply by a negative number, and we've seen this reflection. When there's a negative number out front, then it just flips upside down. So these are just a number of different a values that we can multiply. This is a quadratic we're multiplying by, as we've seen. So it'll give us positive 3 here. Yeah, there's 3, which is pretty stretched. 2.5, so less stretched. And as a decreases, it becomes less affected vertically, and so on. It becomes fractions, which means the function actually opens up and it becomes wider. And then so on. There's 0.1, it's a tenth. 0 just wipes it out, and then it just becomes negative after that. So just a bunch of multiplications there, you can see. Horizontally, given a function y of f of x, will be horizontally stretched or compressed by a factor of 1 over k. So that's the same as 1 over k. It's a fraction when we see k sitting inside of our function. And so for us, we're going to multiply the x coordinates, again, by that fraction 1 over k, whatever that number is. So the horizontal one is a little bit tricky. So if I have a 2 here, f of 2 of x, so the 2 is tucked in with the x. So the 2 is written right beside the x. This is different. I know it doesn't look like it, but that's very different than y equals 2 f of x. If the 2 is out front like this, that's a vertical, up and down. If the 2 is tucked in with the x, that's horizontal. That's what we're talking about now. Okay, so we're not talking about this. That's the previous example. So here, if it's a 2x, I'm going to multiply my x values by 1 over 2. So if k is equal to 2, I multiply all my x values by 1 over 2, a half. So my negative 4, which is here, it's my x value, my negative 4 gets multiplied by 1 over 2. And obviously half of negative 4 is negative 2. So hence this coordinate here now becomes negative 2, 5. The vertical is unchanged. The 5 just stays 5. It's just the horizontal one I'm looking at. So in this case, it's all sort of crunched together horizontally. Quick illustration here as well. Here's our square root function. So we have the basic square root. This is 4, and that's 2 right there, obviously, because the square root of 4 is 2, so that works. If I have this k up here as 4, that means multiply the x values by 1 over 4. So this x value 4 will be multiplied by 1 over 4, which is 1. So I should see a coordinate at 1, 2. 1, 2 right there, which I do. So 1, 2. So basically my first coordinate is 4, 2. And because this is a horizontal compression of 4, which means multiplied by a fourth. Basically, a fourth of 4 is 1. So this thing gets cut basically by 25% and heads down there. Same idea here with the flips. Here's our basic quadratic, x squared. Multiply it by 2. My values are 1 over 2, and so on. Let's take a look at page 119. And again, for all of these, you can always go into Desmos to verify what's happening with the graphs.